salts part of it. All right. So this is the last part of the chapter, and I'd mentioned earlier, this part is going to be like a little information heavy. So it's more know this information more than, figure out based on a particular logic. Salts. What do you know about salts? We have been dealing with salts previously also.
And acids and bases mixed to form salts.
Very nice, correct. Acids and bases react when, like, it's a product of neutralization of acids and bases. The first thing, when someone says salts, the first thing that should come to your mind, what
insoluble substances.
Table salt, would you say that's insoluble?
No, it is highly soluble in water.
Correct. So it's not, I mean, it can be insoluble also, but more often than not, they are soluble. Okay. So solubility, some salts are soluble, some are insoluble. But what are salts? Like, what type of compounds are there?
Ionic.
Absolutely.
Ionic.
Whenever someone talks about salts, the first thing that should come into your brain is that they are ionic compounds. More often than not, like, they are basically neutralization products of acids and bases. And you've seen how salts are formed. Direct neutralization, say you get a lot of salts. If you want any specific salts, you can also make it react with other things like carbonates, bicarbonates, or through displacement reactions, like many ways to get salts. Okay. Salts are how a lot of elements are found in nature. So nature may, rather than elements, salts are like really widely around. So all your minerals and ores basically consist of salts. They are like ionic compounds of all these metals and non-metallic anions. Sodium sulfate, iron oxide, all of these are salts. All of these you find in the Earth's crust, in your soil, in rocks, stones, things like that. Okay. So there are 3 different types of salts. Okay. So salts are basically formed by the reaction of acids and bases. So acids plus bases neutralize to give salt plus water, right? So you have 3 different types of salts. So what type of salt you get will depend on what type of acid and base you are using to produce that salt. So the 3 types of salts are, one is a neutral salt. This is like your table salt that you have. They are neutral, pH 7. And then you have something called acidic salts and basic salts. Okay. So acids and bases can be either strong or weak. So acids and bases, you either have like really strong acids or you have weak acids. Similarly with bases also, you have strong bases or weak bases, right? I'll go from bottom to top. Let's say I am using a weak acid and a strong base. Okay. Now the salt is made of a cation and an anion. So each ion is coming from, like, the anion is coming from the acid and the cation is coming from the base, right? If I use a weak acid and a strong base, which nature is going to dominate, the acidic nature or basic nature?
Basic.
Basic
nature.
Yes. So if we react a weak acid and a strong base, we will end up with a basic salt. Okay. So the best example for this is how you get your carbonates and bicarbonates. So they react with acids, they neutralize acids, they have a basic nature, because they are formed with a weak acid and a strong base. Can any of you identify, if I take sodium carbonate, what is the acid that the salt is coming from and what base it is coming from?
Sodium hydroxide.
Very nice. So
And
sodium
HCO3.
is giving the sodium part of it. So that's a sodium hydroxide is one of the strongest bases. And Puneet, very good. So CO3, the anion is coming from the acid part. So your acid is H2CO3. So H2CO3 is carbonic acid, which we saw earlier is a very, very weak acid. So weak acid and strong base produces a basic salt. Sodium carbonate, if you mix it in water, find out the pH, its pH is going to be less than, greater than 7. It's going to show basic properties. Okay. Similarly, can anyone take a random guess how to produce an acidic salt based on this logic?
Yeah, strong
Strong
acid.
acid plus weak
Acid
base.
plus weak base.
Awesome. So strong acid plus weak base gives an acidic salt. Just like basic salt, acidic salts, when you dissolve them in water and you check the pH, they're going to be less than 7. They tend to show acidic properties. Example of this would be for weak base, consider ammonium hydroxide. NH4OH is one of the weaker bases. Strong acid, any mineral acid, you can take HCl. So ammonium chloride, NH4Cl is an example of an acidic salt. Okay. So this you can logically figure out, like if you can figure out what acid and what base is going to give you that particular salt, it's easy to figure out, okay, is it going to be acidic or basic? And which acid, which base, you can figure out from the positive ion, like cation and anion itself. We'll practice a little bit, like once I'm done with this, I'll practice this with you guys. Okay. And if the strength of acids and bases are like matching, you take like a strong acid, strong acid, strong base, or a weak acid, weak base.
For strong and strong, we can give example as NaCl.
Absolutely.
NaOH plus HCl.
Correct. So HCl plus NaOH, both of them are strong acid, strong base. You get a neutral salt. If you take table salt, mix it in water. If your water is also neutral, Na and Cl also don't have like acidic or basic tendencies. So inka pH will be 7. Even if it varies from 7, it's going to be very, very close to 7. It's going to be a neutral salt. Okay. So yeah, make a note of this. These are the different types of salts. I've given you guys one example in each case. We'll be discussing more examples once you're done noting this down. Yeah. Okay. Again, if anybody did not follow any part, or if you can think of something, if you have any doubts, any questions, yeah, let's do them right away. So instead of nature, you can write it as they are found in nature. Another thing about salts, it's very, very easy to identify them. Think of any ionic compound. If it's not an acid or a base, like if it doesn't have H plus or OH minus ions, then it's going to be a salt.
Ma'am, could you repeat your sentence? I wasn't able to hear it.
Oh, so I was just saying it's very easy to identify salts because if it's not an acid, like you take any ionic compound, and if that ionic compound is not an acid or a base, like if it doesn't have H plus or OH minus ions, then you can be sure that it's a salt. Any ionic compound is a salt. Okay, so we Raghav, Rishita, Vasudha, Shakti, Bhavika are done. One more person was done. They reacted with this, but then it went away. Who was
Ma'am,
Tanisha is done.
can you give
Yeah,
an example of weak acid plus weak base?
yeah, just take a weak acid, weak base from here, right? Ammonium carbonate would be one. Ammonium acetate is another one. Acetic acid also, you can take it as a weak acid. So yeah, after this, I will be going to discuss more examples of the different types of salts. I'll give a list of, strong acids, weak acids, strong bases, weak bases. Mix and match any combination of it, you'll be able to produce salts. And depending on which one it is, you can figure out which salt it is. Like once you note this down, go to the next slide and then I'll discuss more of that. Nice. Most of you are done. Deshna, Divya, Snehal, and Neki. Let me know when you guys are done.
Last time I just joined. What are we doing? Actually, I was having internet issues.
Oh, so Deshna, we just started with salts. What you see in front of you is all we've done. So just had an
Okay, I'll maybe write it down, right?
yes.
I'll take a screenshot for now. I'll write it later.
Sure, that works. But Deshna, just to bring you up to speed, because the next part will not make sense without discussing this. Salts are ionic compounds, and you have different types of salts depending on what acid and what base are reacting to give that salt. So if you have a strong acid, strong base where their pHs are like matching up, you get a neutral salt because they're neutralizing each other. If you have a strong acid but a weak base, because the acid part is strong, it's going to dominate and you get an acidic salt. And if you have a weak acid, strong base, because the basic nature is dominating, you end up with a basic salt. Okay, so these are the basics of it.
Yes, ma'am, got it.
Cool. All right. Nikki, you're noting it down or are you done? Almost done.
Yeah, almost done. Just a second.
Okay. All right. Flipping then.
Yeah, done, ma'am.
Okay. All right. I'll just give you guys a list of strong acids, strong bases, and then we'll practice identifying whether that's going to give a acidic salt, basic salt, or neutral salt. Okay. List of strong acids. This you guys would be familiar with. Start off with HCl. What other acids do you know which are strong?
H2SO4,
Very nice.
HNO3.
HNO3, yes. Okay. Next, weak acids.
Carbonic acid.
Sorry, which acid, Abhi?
H2CO3.
H2CO3, yes. Abir was mentioning some acid.
CH3COH.
CH3COH, yes, acetic acid. When it comes to formula, yeah, this is the thing. But apart from that, yes, organic acids, like if it is given in terms of words, so you have malic acid.
We have formula for citrus acid around?
Acetic acid.
Acetic acid, we already covered CH3COH.
Formic acid.
Formic acid, yes. Formic acid ka formula
Lactic acid.
easy. Formic acid is HCOOH, and this is the H that's going to take part in reactions. Lactic acid, yes.
Can
Ascorbic
you give
acid.
formula for
Citric acid, someone said, right? Formula for citric acid, I can Google search it. It's an organic acid. It's going to be a little difficult, like not difficult, complex.
yeah, but then if we are supposed to use in equations, then we will have to know the formula.
Oh, you won't get these kind of acids in equations. Definitely not. Maximum you'll get carbonates, acetates, and this again, this is like really out there, but just giving you just
Okay.
for information. Right? Yeah.
Ma'am, tartaric acid.
Tartaric acid also, yes. So citric acid ka structure, just in case you're curious, it looks like this. Oh, this is quite complex. It's got a lot of carbon atoms. So it's got a COOH, and then that's bonded to another CH2, and then it's C. This is connected to another COOH. So this has an alcoholic group, then CH2, and then COOH. So yeah, you won't be asked like this complicated stuff. Like when we do organic chemistry, we'll go deeper into it. That's like it will start making sense then. Let it be for now. Okay, so these are some of the strong acids and some of the weak acids. These names I've given because just in case you get names like sodium citrate. So is that going to be an acidic salt or a basic salt?
Basic salt.
So if I tell you sodium citrate. So Bhavika's got it. Mansi answered. I'll tell you guys the correct answer once more people attempted. So sodium citrate will be acidic salt or a basic salt?
Basic salt.
Absolutely. So sodium is coming from NaOH. Citrate is coming from citric acid. Citric acid is weak. NaOH is strong. So this will be a basic salt. Okay. Nice. Neki sent a very in detailed answer. Good. Strong bases, you have your NaOH, KOH. So basically, ALOH thrice, yes. So basically, if you have highly reactive metals, hydroxides, that is going to be a strong base. But if you have a mid-range, like medium reactive metal, then that will fall under a weak base. Like sodium, potassium, calcium, magnesium, all of these are basically reactive metals. So their hydroxides are going to be quite strong. And when it comes to weak bases, oxides or hydroxides of lesser reactive metals like copper hydroxide will be a weak base. Ammonium hydroxide is a weak base. Iron, like if there is a hydroxide formed from iron or iron oxides are going to be a weak base. Okay.
What about zinc?
What about?
Zinc? Does it also form?
Zinc also would be moderate. Like it is definitely not a strong base. It would come under like one of the weak bases.
Because when we are doing reactions, we say that zinc is more reactive than iron, and then iron is more reactive than copper.
Absolutely. Now again, all of them are not equal, right? Obviously, it like again, if we want to speak accurately, base pH goes all the way from 7 to 14. Okay. So where do you draw the line? Like obviously some are going to be weaker than other bases. Some are going to be like somewhere right in the middle. So this is more of a more or less roughly, practically speaking, for the sake of answering question or, for practical purposes, that's why it's done. But yeah, it's not like a binary thing where it's either strong or weak. It is a continuous thing where some of them are extremely strong, some of them are extremely weak, a lot of them fall somewhere in the middle that way.
Ma'am,
Yeah.
recently we had to make a PPT on balancing equation. So in that, one of the equation was P4O10 plus 6H2O is equal to H3PO4.
One second,
give
Nikki, I'll just write it down here. So you have P4O10 plus
6H2O,
okay,
which gives 4H3PO4.
4H3PO4. Okay, phosphoric acid. All right.
Yeah, so can you give the names of all these?
Oh,
H2O and
H2O is water. P4O10 is phosphorus pentoxide. And H3PO4 is phosphoric acid. So phosphoric acid.
Phosphoric acid will be strong, right?
Yes, it is one of the strong acids. It's one of the mineral acids. So yeah.
so phosphorus pentoxide, we can write it as PO5. Like we don't need, sorry, P2O5.
Yeah, so it is also represented as P2O5, but it's not interchangeable. Like sometimes P2O5 is less stable, which is why, two of these molecules combine and exist as a pair. So that the technical scientific term for that is called a dimer. That is the reason a lot of places you'll find P4O10 and not P2O5.
Okay.
Here. So these are like some of the examples of strong acids, weak acids. So, okay. So if I give a salt like sodium carbonate, we already discussed. Let's look at ammonium carbonate. So first, figure out what acid and base is this formed from. What acid and what base? So just to
Do
make
you have to write it in the chat?
You can write it in the chat, yes. So this is ammonium carbonate. And everybody should answer, okay? Puneet, yes, but what acid and what base is it formed from? Mansi, yes, you got one of the reactants, right? Yes, Puneet, you almost got it right. Check the formula. I don't know if it's like a typo or if you genuinely made a mistake. Check the formula. Anirban, no. Like CO3 is an ion, like CO3 2 minus is the carbonate ion. So you need to add a cation to it to form, an acid or a base. And then you interchange your acid and like you just split it into two separate ions. The ions are not acidic or basic. Puneet, yes, now you got the acidic part, right? Nikki, Oh, both of them are weak acid. I think you typed that by mistake, but otherwise components are absolutely right. You identified it. Abhishek Trivedi, correct. Vasudha, you identified the ions. Now figure out what acid and what base they would have come from.
Ma'am, you said that I did by mistake, but I think you have put H2CO3 in the weak acid column only.
That is correct. The other one is not correct. I think you wrote it by mistake.
And again, NH4OH is also put under weak base, right?
Yeah, you typed weak acid there.
Oh yeah, sorry.
Elena got it. Rishita got it. Abhishek, yes. Mansi Rathi, correct. Oh, not, I mean, NH4OH is strong or weak? The components, yeah, which is acid, which is base, you got it right. But whether it's strong or weak, that you need to check. Okay. Some of you, like a lot of you got it correct, but some of you have gotten confused. Neil Prajapati, yes, absolutely right. Anirban, again, that's just an ion. You need to find out where that ion has come from. I'll discuss soon. Okay. Tanisha, yes, you got it. Shakti, one of the components, that is correct. Okay, Vasudha and Anirban, out of the people who have answered so far, Vasudha and Anirban, you have identified the ions correctly. So you have NH4 plus, in fact, you have two of them, and you have carbonate ion, CO3 2 minus. Now, these are just ions that the salt is made of. So these ions should have come from something. Like our salt is made from acid plus base, right? So whatever ions that salt has should have come from either the acid or the base. So you need to figure out kahan se NH4 plus aaya, like where did this particular ion come from? Which acid or which base did it come from? So can you figure out where NH4 plus could have come from? Which acid or base has this particular ion? Yes, Vasudha, got it. Anirban, what about you? Check carefully. Nitric you don't have NH4, you have HNO3, which will technically split into H plus and NO3 minus. NH4 तो कहीं पे दिख नहीं रहा है ना nitric में. So check again. And whoever has not answered yet, I'm like, you guys can still go ahead. It's not like the end of this thing. Sulfuric में NH किधर से आया निर्वाण? Don't just randomly guess. Check where NH4 is. And don't just restrict yourself to acids. Like it could have come from acid or a base. So check the whole list. In the meantime,
So ma'am, here we have to specify the acid and the base involved, or do we write if we do that, right?
no, specify which acid, which base it's come from. Like I want you guys to practice that first, and then we can go on to figuring out if it is weak or strong directly. Yes. Ritvik, yeah. Vasudha, yes, absolutely. You got the acid and the base. Anirban, correct. So NH4 plus, if you look at the list, NH4OH may direct, this itself is the cation, right? So that's where it's coming from. So your base is NH4OH, absolutely right. Similarly, where is CO3 2 minus coming from? Which acid or a base is it? Very good, yes. So the acid, you can see directly carbonic acid, weak acid ke andar hai. So this is H2CO3. So now that you're able to figure out which acid, or now that you figured out which acid and which base, what some of you have already given this answer, but those who have not attempted it yet, what kind of acid or base, like is it strong acid, strong base, weak acid, weak base? Like how would you classify these two? Nice. Shakti and Elena is sent it. Anirban, yes. So both of them are weak. Raghav, yes. So which means that overall ammonium carbonate will be what kind of a salt? Very nice, cool. Yeah, so that's kind of how you would identify it. Like if you find it, like whatever stage you find it difficult, break it down, figure out which acid, which base it's coming from. If you're finding it difficult, if you're not confident, you can write down each step. But eventually,
Ma'am, is it neutral?
yes, it is a neutral salt. So Anirban, you sent weak salt. No, weak salt, strong salt, kuch hota nahi hai. It's either neutral or acidic or basic. Okay. So this would be more or less neutral. Like it will tend to have some pH. It would depend on how much carbonate, how much ammonium you've taken. If you took equal amount, same pH, तो फिर neutral हो जाएगा. Otherwise, it'll be slightly more towards this side or that side. Okay. But yes, so salts का भी pH होता है. If what you're taking is evenly matched, it would be more or less neutral. If one of them is dominating, it's going to have a different pH. Okay. So this time I'll give you guys the name of the salt. Potassium formate. So 3-step. 1, figure out which acid plus base. And 2nd step, what is the type of acid and base? And then 3rd step, figure out what type of salt is it.
Ma'am, what's the formula for formate?
This is HCOOH.
Oh, it's basically COOH.
HCOOK. Potassium
Okay.
formate is HCOOK. So this is the always organic acid may the hydrogen attached to oxygen is the one that is acidic. It's the one that will get replaced. Mansi, I hope it clarified. So oxygen ka jo hydrogen hai, that is the one that gets replaced. So it will be HCOOK, not COHK. Okay. Rishita identified acid and base, and so it's going to be Very nice. You got it. Correct. Abhishek Trivedi also got it. Yes. Shakti got it. Hey, HCOOH. पूरा नाम लिखना है what acid it came from, but yes. Acid, you got it correctly. Raghav, correct. You identified acid and the base. Shakti, yes, you got the whole thing. Avir got it. Raghav got it, yes. And Vasudha, yeah, identified the acid and the base. Excellent. Yes, correct. Raghav got the whole thing. Ritvik, correct, acid and base. Elena, correct, acid, correct, base. And where did it go? Yeah, you got the whole thing right. Ritvik got it. Deshna got it. Puneet got it. Yes. Neil got it. Mansi got it. Very nice. So Mansi, because valency 1, this is not repeating multiple times, right? So you don't have to put it in brackets. Only when this HCOO altogether has like 2 or 3 or something, then you put it in bracket. Otherwise, not necessary. Anirban, it's not a base, but yes, I think you got it. Neki got the whole thing. Neil got the whole thing. Very good. So Snehal, Tanisha, Ryan, haven't sent it. Divya and Dhruv, I hadn't called out your name also, right? Ame, I haven't got an answer from you also. Mansi got it, yes. Correct. Final answer is right. If anybody is confused, if you're still not able to figure out, you should let me know now. Like, it'll be easier to clarify it now itself. No, Anirban, not acidic. Jaden, yes, you identified. No, wait, Jaden, you didn't get the acid correctly. CH3 किधर से आया? It's potassium formate. I've given the formula also. HCOOK. CH3 तो नहीं है ना? Bhavika got it. Absolutely. Anirban, all salts are natural. So natural salt karke, there's no specific thing. Okay. So acid and the base, you have identified correctly. Acid is the HCOO part. So that's HCOO. Acid hai, to hydrogen ionizer. Base, potassium, you're getting from KOH. So acid is strong, base is weak. Sorry, it's the other way around. KOH is strong and acid, formic acid, organic acid hai, so that is weak. And so weak acid, strong base, so what type of salt?
Basic.
Basic salt, yes. Yeah. Again, Tanisha, you also sent strong salt. Nahin, like there's nothing called strong salt, weak salt. Salt ka aise kuch strength nahi hota hai. So it's either acidic or basic or neutral. Yeah, basic is right. Okay. Okay. One more. Actually, I'll just. So the salt is potassium sulphate. This time, directly tell me what is the type of salt. If you're not able to figure that out, like you can either answer for 1 or 2 or 3. But if you're able to get to 3, answer 3 directly. Anirban, again, sulfate, SO4 is just the ion. It is 1/2 of it. So वो acid base नहीं हो सकता है. You need to figure out where that SO4 is coming from. Mansi got it. Very nice. Oh, Rishita, check where your base falls, strong or weak. But otherwise, still there, it's right. Neki, correct. Anirban, yes, now you got it.
What's H2SO3?
H2SO3 is sulfurous acid. So it is slightly weaker than sulfuric acid. But yeah, it's one of the mineral acids. So some elements, especially sulfur, potassium, like the elements that are that have atomic number more than 10, around 13 or so, like right from silicon, I think, they start having multiple valencies. So until now, you guys have been dealing with single valency, like sodium is always +1, aluminium is +3. But from element 14, from silicon, phosphorus onwards, you will find elements having multiple valencies, like the way you come across copper and iron. Right? So that way, with one valency, sulfuric acid is formed, and with the other valency, sulfurous acid is formed. In the meantime, yes, Anirban, you got the acid. Raghav, correct. Puneet, correct. Alina, correct. Rishita, your base is correct. Yeah, so based on that, your answer will be modified. Neil, either you made a mistake in the spelling. Natural salt नहीं होता है, या तो neutral होता है, acidic होता है, या फिर basic होता है. Okay. Anirban, where does KOH fall? Strong or weak? Check your list. Jaden, acid base, you got it right. Tell me the type of salt based on that. Tanisha, yes, you got it. Deshna, correct. Shakti, correct. Nihil, yes, spelling mistake tha, theek hai. Anirban, yes, now you identified. So will the salt be acidic, basic, or neutral? Okay, whose name did I not call out? Abhishek Trivedi, the last potassium sulphate कब नहीं भेजा है ना अभी तक. Abir also you haven't sent it. Ame, I am not getting any response from you, Ame. Anirban, you have been sending. Bhavika, yes, now I got it. Absolutely right. Ritvik Vishal, acid base is correct. Vasudha, your acid and base are correct. Just give me the type of salt. Final answer. Deshna, Dhruv, I think you sent it, right? Okay. Call out your name. Yeah, just scroll. Divya is okay. Elena sent it, yes. Jaden, potassium sulfate का आंसर नहीं आया ना? Abhishek has sent it, correct. Neil sent it, Nikki sent it, Mansi sent, Puneet. Ryan Gandhi, I didn't get answer from you also. Raghav, Rishita, Ritvik, Shakti, you all have sent. Snehal Kashyap, I have not received from you. Okay. Barring 4 or 5 people, yes, everybody has gotten it. Just take care of your spellings and things. Like abhi pura online hi hone wala hai. So build good habits. Don't miss out on, silly things like this. Okay, you want to do more of this, or should we proceed with, go to the next concept? Concept. Okay. So let me know if anybody is not feeling confident or you want to do like one last thing. Otherwise, I will go to the next concept. One more. Okay. Anirban, yeah, you want to get it? Yes. Get this one correct. Like check everything carefully and do this properly. Okay. Check. Okay. Once are solved. Ferrous sulfate, FeSO4. So just answer acidic, basic, or neutral. If I call out your name and I tell that your answer is wrong, then let me know what acid, what base you found. Okay, so let's finish this up quickly. Simply send whether you think this is acidic, basic, or neutral.
I got disconnected. Can you tell what we have to do?
Okay, we are doing the same thing. So the new salt I've given is ferrous sulfate. Just send me whether it's acidic, basic, or neutral.
Okay.
Anirban, wrong. You identified the acid and partly the base, but your final, what type of salt it is, there you've gone wrong. Ritvik, yes. Neki, yes. Bhavika, yes. Raghav, yes. Shakti, just tell me if it is acidic, basic, or neutral. But yeah, your acid and base are correct. Neil, correct. Ryan, your answer is wrong. So tell me what acid and what base you got. So based on that, I can check where you went wrong. Jaden, yes. Deshna, yes. Abhishek, yes. Shakti, yeah, step 2, you got it right. But send me the final answer. Anirban, yeah, your acid and base are correct, but whether it's acidic or basic, that's where you went wrong. So just try again. Elena, correct. Shakti, yes, finally correct. Puneet, correct. Yeah, Anirban, now you got it. Absolutely right. Tanisha, correct. Abir is correct. Who else is trying? Vasudha, Snehal, Sarah. Rishita, did I call out your name? Did you send an answer? Don't remember.
No, ma'am, I'm
Figuring out. Okay. Ritvik, Raghav, Ryan, they sent it. Puneet also I got. Neki. Neki, yes, you answered. That is right. Neil also sent. Neil, you sent it for this the final question, right? Ferrous sulfate ke liye?
Yes, ma'am.
Okay. Mansi, I think, sent it. Jaden, yes. Awesome. Rishita, you got it right. Elena got it. Deshna. Amey Sonkhaskar, I don't think I received from you. Snehal, what you sent? Random message. Okay. Mansi, yes, correct. Ryan, the one you sent was wrong. Can you send me what acid and what base you like? Can you send me what was your step 1 here? Answer for this. Vasudha, yes, got it. So Vasudha, now you just have to send what is the type of salt. Your acid and base, you got it. Okay. Ryan, you made the same mistake as Anirban. Did you pay attention earlier? Acid SO4 is, yes, SO4 is coming from acid, but that itself is not the acid. That SO4 2 minus ion should come from somewhere, right? So this part, kaun sa acid se aa raha hai? Like, can you find in this whole list strong acids, weak acids, where you find SO4? So that would be your acid. And Fe part you're getting from base, but which base? Fe is just one single ion in ferrous sulfate. Okay, so SO4 you can see it's coming from H2SO4. So that is your acid. And Fe, if you look at the list of bases, it's coming from FeOH twice. So this is your acid and your base. Now you can see that type of acid H2SO4 is a strong acid and FeSO4 is a weak base. So अगर acid strong है, base weak है, so acid part is going to dominate. So the type of salt, ferrous sulfate, is usually an acidic salt. ठीक है? अभी आया. ये take care of your formula. FeOH twice. Fe का valency 2 है, like in this context. Yeah. So practice a little bit. Questions आएंगे. Okay. Going to the next part. The rest of the chapter is like extremely theoretical. We'll just be going over some common salts that you use in your day-to-day life and how they are prepared. One, like the reactions associated with it, and number two, what are their uses? These are like the main things. Okay, different type of salts, and there you go, some common salts and their properties. Sorry, their uses. So before all of these, the most widely available salt is sodium chloride, NaCl, like your table salt. That is the first salt that anybody knows, like in their life. The salt is their table salt. Who can tell me, where do you find NaCl in nature? Where will you get it from?
Water bodies like oceans and
Water.
sea.
Awesome. So somebody said water bodies, right? Specifically one water body, which is ocean water. You don't get salt from.
Yes, ma'am. I said water bodies like oceans.
Absolutely. So, I mean, that's again a long sentence, right? You can straightforward say seas and oceans. That's it. Okay. Yes, sea. How will you get NaCl from seawater? What process can you apply to do that?
Evaporation or Acceptance, hard sieving.
Yeah, so that's literally how salt is extracted from seawater. It is the most straightforward process that anybody can think of, which is evaporation. So I don't know if anybody, like all of you live in Mumbai, if anybody has like gone on a road trip, if you've seen these salt farms outside the city. I'll just show an image. Yeah. Hi Abir, yeah, what's up? Raise your hand.
No, mom, just one step.
Oh.
Ma'am,
Yeah.
sodium hydroxide is a base, right?
Yes.
So on the screen you were sharing, it was written as a salt.
Yeah, that's technically not a salt, but we study it because we talk about its preparation, and sodium hydroxide itself is used in preparation of a lot of salt. That's like a raw material for that. That's the reason it's given, and it's a compound of sodium. That's why it's like included along with the rest. Okay. All right, so this is what salt farms look like. So what people do is, it is obviously located close to the sea, and people build like embankments, like enclosures where they trap the seawater. So you have like shallow pools of seawater, and then they just let nature do its thing. So when water evaporates off, this is kind of, the kind of scene that you see. And as the salt starts forming, you can, like people, they rake that salt, they collect it in a certain place. This is literally in Badala salt form, Bombay. So next time any of you go on a road trip, if you're passing by any of these areas, keep an eye out, like look towards the sea. You'll find a lot of salt farms. Okay, so how the salt gets from the seawater to your table is basically, it goes through multiple processing. It doesn't come directly from the sea to your table. So first what happens is, from the sea, it is evaporated. So first evaporation takes place. The second is purification. So salt, like NaCl, is not the only salt that exists in seawater. You also have other impurities, like you have like sand, you have other salts like MgCl2, you have KCl is another salt that you find a lot in seawater. So NaCl is not the only salt. You'll find a lot of other impurities mixed up. So when the evaporation takes place, along with NaCl, you get a lot of impurities, right, after evaporation. So the next step is purifying it. Like you separate out NaCl from all the other impurities. For purification, again, depending on which impurity you're separating out, many different methods can be applied. So one is filtration directly. So if it is stuff like sand, you can directly filter it out. Second is, again, you have different chemical processes, like things that will leave NaCl alone, but if it has the capability of, taking out only KCl or MgCl2, then you use those methods. So that particular chemical process will separate these out, leave NaCl alone. And another major, like the final step to get almost 100% purified, almost 100%, almost like it would be close to 99% or so, is crystallization. This is like a surefire way to get pure NaCl. So crystallization is a process of building crystals. So what you do is, actually we guys studied crystallization in grade 9, right? How many of you remember what that process is like?
Giving out like solid pure forms.
Yeah. So you take a solution of that particular salt, dissolve it, make like a completely saturated solution of it, and then you plant like one small seed, like take a tiny sodium chloride rock, and then over time there it grows into a really large crystal of sodium chloride. It's not just for sodium chloride. This method is to build any solid crystal of a salt, but yeah, so you can use that to get pure sodium chloride. And after that, additional processing, like depending on how it's packaged. If it is kosher salt, then it's like ground into coarse grains. If it's like table salt, then it's ground into a fine powder. If it's like rock salt, then the granules or the stones are slightly bigger. Iodized salt ke liye add a little bit of iodine into it. So packaging ke liye whatever processes are required, further processing takes place, then it is packaged and then sent to all the shops. Okay, so that's how you get sodium chloride. And sodium chloride is extracted not simply for cooking or like household purposes, but it has a lot of industrial uses. So sodium chloride is the source material for many of sodium compounds. So sodium chloride mixed with water, so mixture of NaCl and H2O, basically salt water. In industrial or scientific terms, it's called brine. So brine is basically like you mix brine with other things, or you apply electricity through it to it, or basically you take brine and do different things to it to get different sodium compounds. Okay, so one such compound that we'll be talking about right now is caustic soda. So caustic soda is the common name for sodium hydroxide. Chemical name, you guys know sodium hydroxide is NaOH. How it is prepared is electricity is passed through aqueous solution of sodium chloride. Now this part is very, very important. Keyword being aqueous solution of sodium chloride. If you take molten sodium chloride, you will not get caustic soda, you'll get something else altogether. You need to pass electricity through aqueous solution of sodium chloride. So this process is called chloralkali process. The reason why it's called chloralkali, once I go through the process, it will get clear. And yeah, this is the overall general equation that is involved in this particular scenario. Okay. So before we get into chloralkali process, right? Make a table in your book and make it in this format. So at the very least, have a column for the common name of the salt, then a column for chemical name, and then the column for formula. This is like really, really important because this is one of the most commonly asked questions, at least for 1 marker and things. Like since you have an MCQ proper right now, you need to learn this. What is the common name, chemical name, formula? So by the end of this, once we go over these 4-5 salts in detail, I will also take you guys to, oh, there's more salts given right here. That's cool. Other salts you have like chemical name, common name, chemical name, formula. So we'll fill up that table. So ensure that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rows. 10 rows with common name, chemical name, and formula.
And the common name and the short name may be the same, right?
Yeah. But in your book, write it as a common name so that it's like clear. that it is the common name of that salt.
Do we have to write this table?
We will fill it up slowly as we go through each part. For the first row, write caustic soda. Chemical name is sodium hydroxide. Formula is NaOH. Then leave gap, like you will have 10 rows totally, like 10 salts. And chloralkali process, you can write it down after that.
So do we need to
Okay.
mention preparation and uses?
No, because preparation uses making a table, it's going to take a lot of space. And this whole section is theory, like whatever we'll be discussing, you will need to learn that. So either you can write it in like short form or you can read through it. The important points I'm going to tell you to note down anyway. So, table, just keep it to common name, chemical name, and formula.
Also, must can you move on to the whiteboard?
Okay.
I mean, the NaCl one.
Oh, you're noting down these points, is it? NaCl, there's not much. You can include that in your
Done.
common name, chemical name also. It's called different names. You call it table salt, rock salt. Chemical name is sodium chloride. NaCl is the formula. You can include that. But yeah, your table, write it as common name, chemical name, and formula. And once you've written the heading, leave gap for, you need to have 11 rows, 11 lines. So depending, like if you're using a ruled book, it's easy, just like count 11 lines. If you're not using a ruled book, figure it out based on your writing, how much space would be required, but you'll be taking down 11 points in this table. So leave enough gap and continue from that.
But why are we leaving gaps? We are just writing down right now, right?
I won't be giving all 11 at the same time. Like I'll be doing each compound at a time. So when we come across that, you can write the common name, chemical name, formula. In the meantime, like for chloralkali process, I'll go into a little bit of detail. So if you need to take down additional notes, write it below the table.
Okay, got that.
So let me know when you're done with this. I'll continue with the chloralkali process. This requires a little bit of focus. So let me know when you're done so that you can pay attention here.
Mom, I just got disconnected. What did you say?
What part did you miss, Shakti? Like what point did you get disconnected?
I don't know why you've written the common name, chemical name, and formula.
Oh, so you started the salt part of it, right?
Okay.
So for the salt, this is quite important. Make a table, common name, chemical name, formula. We'll be writing 11 salts in this. We'll be covering 11 salts. So give yourselves 11 rows. And then after that, yeah, like whatever extra notes are there, continue writing from below that.
Okay, ma'am.
Have you guys done the chapter on electricity in physics or only light so far?
I'm done.
We have done it.
Done electricity.
Now we have done.
I am basically done with like 75% of physics done.
We had done electrolysis also in earlier.
Electrolysis where? When?
It was not this year.
Okay. Yeah. Yeah, electrolysis, yeah, you would have had in like 7th or 8th grade, right? Earlier. Okay, Anirban is done. Mansi is done. Amay is done. Okay. 4 people are done. Okay. Puneet, Shakti, Elena, Bhavika. Okay. Meghi, Tanisha, Rishita, Sarah. It's good that you guys have done electrolysis because we'll be revisiting that. That part is required here. Dhruv, yes, Sarah, okay. Abhishek, Divya, Jaden, Neil, Ryan, Raghav, Ritvik, Snehal. Whoever has raised their hands, you have filled up the first 2 rows, right?
Yes, ma'am.
So first
Yes,
row,
ma'am.
yeah, table salt / rock salt. Then second one being caustic soda.
Ma'am, we say like when we are eating in day-to-day life, table salt and rock salt are 2 different things, right?
In terms of packaging and uses, they're different, but it's like chemically they're the same.
And what about black salt?
Black salt is NaCl itself, but mixed with some impurities. That's what, and that's the reason like Himalayan pink salt, like pink salt or Himalayan salt is also another thing that's coming up. That's also NaCl, but mixed with some impurities. And the impurities, not harmful impurities, just stuff other than NaCl. And that is what gives it a different color and taste and all of that. Actually Google and tell you guys what exactly black salt is made of. Yeah, there you go. It is kiln-fired rock salt. It's got a sulfurous, it's got like a pungent smell. So I think there's some sort of a sulfur related compound in it.
Ma'am, do we have to draw this diagram also?
I'll discuss it. If you're free, yes, you can. You can draw it in a very simple way. You don't have to draw it so detailed. Just draw the tank, 2 electrodes joined by a battery and liquid. So the naming and all, when I discuss chloralkali process, I'll give it to you in detail. So once that process is done, you can note it down. I'll give you guys time. It'll be a good revision also for you. Abhishek, Neil, Ryan, Raghav, Rishita, Sarah, and Snehal. Snehal is done, okay. You guys will take time or you don't have to fill up the table abhi. Oh, okay. You guys were sleeping or what? All right. So just Abhishek, I'm waiting for then right now. Done. Okay. All right. So no writing for now. I'll give you guys time to note it down later. Just pay attention and yeah, participate here. Like just focus on the concept here. Okay. So chloralkali process, the raw materials are brine. So brine is basically solution of sodium chloride with water. So it's basically salt water. Okay. So you take brine in a large tank and you need to do electrolysis of brine. So that is going to give you caustic soda, NaOH, with some side products, byproducts. Okay. How is this taking place? Like what's going on at the chemical level? How is salt turning into sodium hydroxide? So if you take NaCl in water, what all ions does the solution contain?
Na plus, Cl minus.
negative, H plus, and O negative. O2.
Very nice. Correct. NaCl is going to dissociate into Na plus and Cl minus. Usme se ye do ions are water say you're getting H plus and OH minus. So all these 4 ions are like just swimming around in this liquid. Okay. Now we connected the 2 electrodes to a battery. So according as per the battery, you get a positive electrode and a negative electrode. So what is the positive electrode called? Who remembers?
Cathode.
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 Got confused. Electrode.
Cathode.
No,
Anode.
it's the other way around. Positive electrode is the anode. And the negative electrode is the cathode. Okay, now this will make sense in the next 30 seconds. Okay, forget about the names for a while. Tumhare solution mein you have cations and anions. Cations, your basically Na plus and H plus, will move towards positive electrode or negative electrode?
Cathode, because negative.
A negative
charge.
electrode.
Correct. So positive ions will get attracted to negative charge. It will move towards the negative electrode. So your Na plus and H plus are going to move towards the negative electrode. So because you have cations moving towards this electrode, the negative electrode is called cathode. That's why you have the word cat over there. Yeah, so that is the logic. So now it should not confuse you. Cations matlab cathode. And cations positive hote hai, isliye the negative electrode is cathode. Similarly, Cl minus and OH minus, anions will move towards which electrode?
Anode.
No.
Anode.
Anode.
It'll move towards the positive electrodes. And because this electrode is attracting the negative ions, Cl minus and OH minus, because this electrode is attracting anions, it is called anode. Okay. Cations cathode, anions anode. Now you should never get confused in your life. Okay. Okay. So let's take each electrode one by one. So at cathode ke paas you have Na plus and H plus. These 2 ions are there. Between Na plus and H plus, which is more reactive?
Na plus, sodium.
Plus.
Na plus is more reactive.
Plus.
Correct. So Na plus more reactive matlab, it will want to stay as Na plus for as much time as possible. It doesn't want to turn into its elemental state. So that is why H plus is the one that gains electrons from the cathode. So 2 of these H plus ions gains 2 electrons and turns into H2 gas, which escapes out at the cathode. Okay. Similarly, at anode, you have OH minus and Cl minus. Both these ions are there at the anode. So out of these two, because of the electrode potential, like because of the chemical properties, Cl minus is the one that tends to lose electrons, gives out the 2 electrons to the positively charged anode, and escapes out as a chlorine gas. So chlorine gas is what do you call it? Liberated at anode, Cl2. Okay. So this part is really, really important. At cathode, you get hydrogen gas, and at anode, you get chlorine gas. So finally, what is remaining in the solution?
Sodium and hydroxide.
Sodium and hydroxide ion.
Yeah, sodium and hydroxide, sodium ions and hydroxide ions. So these two are like, they basically attract each other and they form NaOH, which is basically let out. So from the bottom of the tank, you get the NaOH that is formed. And yeah, from this, you just attach it to pipes and you can take it wherever.
Ma'am,
Yeah.
like Na and OH is forming NaOH, so why doesn't it forms HCl?
Because H plus is gone towards cathode and Cl minus is gone towards the anode, right? So even if
And OS are also gone, no?
Oh, yeah, even they both are at different electrodes.
they also
right?
exist, they're there, but because H plus is the one that preferably takes electrons turning into H2 gas, Na is going to like take a step back. Like it's not going to take part. It's not going to be like H plus is the one that's going to surround the cathode and turn into H2 gas. So Na plus is just there in the solution, it's chilling. And as you keep losing H plus and Cl minus, what is remaining is just Na plus and OH minus. So again, like applying electricity, all of that is in your hands. So what you can do is you can conduct the electrolysis to remove H plus, like hydrogen and chlorine, and what is left in the solution is just Na and OH. So if electricity is no longer running through these electrodes, there's nothing else that Na plus and OH minus can do, right? So that will remain in the solution and you can take it out as NaOH. Does that make sense? Like, does that clarify? Nikki?
That you switch off the electricity in between, that part.
Yeah. So basically you can control the amount of electricity so that the
Say
reaction.
like that. So if we are saying like that, then how do we know if all the ions are at the are present at the electrodes? Like if there are the solution won't have only one atom or one ion, right?
That is true. So another thing you need to remember is all of this is controlled. You don't leave it to nature. Like other than the fact that these ions are attracted to these electrodes, one, the quantity of NaCl, like brine water that you take, is controlled. Two, the amount of electricity that you pass through the electrodes is controlled. So basically you are controlling the rate of the reaction that's happening within this tank. That's the whole point of industries. Like if you're not able to control it, there is a risk of explosion happening, because if it's an exothermic, you're playing around with electricity, a lot of fire hazards and everything. So controlling the quantity and the amount of electricity means that if you measure how much hydrogen and how much chlorine you got out of it, you can make an estimate as to how far the reaction has proceeded. So that way you can estimate based on how much salt water you sent in. Okay, I got like 3 liters of chlorine and 3 liters of hydrogen, which means that majority of the tank is filled with NaOH only. So you can make an estimate by constantly measuring different aspects of this particular reaction. Different aspects as in how much raw material you put in, how much electricity you've provided, how much of the byproducts you've gotten out of it. And based on that, you can estimate, okay, how much NaOH you got at the end of it. So that way you can control, you can slow down the reaction, you can speed up the reaction, you can do all of these things.
Yeah, got it.
Yeah. So yeah, that is the process of production of caustic soda, sodium hydroxide in an industry, commercial production. Now, the reason why it's called chlor-alkali process is it comes from the process itself. So the main products, like apart from hydrogen, the main products of the reaction are chlorine gas and sodium hydroxide, which is an alkali. So the chlor part of it comes from chlorine gas, chlor, and the alkali part of it comes from sodium hydroxide being produced here. Now, because these are like the major products of this process, it is called chlor-alkali process. Yeah. So the main points of this is, one, you need to
Ma'am, can you repeat
yeah, just
why
summarize.
it's called chlor-alkali?
Oh, chlor-alkali is simple. So one of the major products is chlorine. That's where the chlor part of it comes from. Chlorine, say chlor. And the other major part is alkali. Alkali is basically a base that is soluble in water, and NaOH is soluble in water. NaOH, KOH, these are called alkalis or alkalis. That's where the alkali part comes from. Oh, another thing, I don't think we have discussed this before. So how we say basic nature, another word that is used in its place is alkaline. Like basic solution, call it an alkaline solution. So alkaline solution means nothing but the fact that uska pH is greater than 7. Yeah. So the word alkaline comes from the fact that, in the olden days, before people could figure out the chemical compositions and all of that, they called a solution of NaOH as alkali. Acid and alkali, they were like opposite to each other. Basically, it's a ship name of whatever products you're getting here. Chlorine, say chlor, and alkali, say alkali. That's why it's called chlor-alkali process. Okay, so summarizing the whole thing once. So chlor-alkali process is the process of manufacture of NaOH, also called caustic soda or sodium hydroxide. The raw materials that are required to manufacture NaOH is brine. So brine is nothing but it's basically salt water. So you take some salt, sodium chloride, water, mix it in water, like a really salty water is sodium chloride. Okay, that's brine. So take brine and electrolyze it. Like it's produced from the electrolysis of brine. So electrolysis matlab you subject it to electricity. What happens, how sodium hydroxide is created is that by the magic of electricity, okay, don't write this in the exam, the ions that you get from brine. So from the brine solution, H+ ions are attracted towards the negatively charged cathode, and they gain the electrons from cathode and they escape as hydrogen gas. chloride ions lose the electrons to the anode, and it is released as chlorine gas at the anode. And what is remaining in the solution is your sodium ion and hydroxide ion. So remaining sodium and hydroxide ions in the solution combine to form your sodium hydroxide solution. And sodium hydroxide, being in liquid state, is collected from the bottom of the tank through an outlet. And yeah, that's how you get caustic soda. That's how you get NaOH. Okay. And interesting part, like one of the popular questions you get from this is why it is called chloralkali process is based on the products that you get from this particular process. So one of the major products is chlorine, and the other product is an alkali with sodium hydroxide, which is an alkali. So it's a combination of both these words. So chlorine plus alkali, you get chloralkali process. That's it. ठीक है? All right. I'm guessing that you guys are noting this down. Note this down and let me know when you're done. In case you have any questions or doubts in any part of this, let me know and I'll answer it. Okay, so I was just mentioning, yeah, fill up the second row, bleaching powder. Bleaching powder is, yeah, your regular bleaching powder. Chemically, it's calcium oxychloride. Formula is just like what the name is telling you. Calcium, oxy, एक oxygen atom होगा, and then chloride, so CaOCl2. This is the formula of bleaching powder. Okay. How bleaching powder is produced is you need calcium, you need oxygen, and you need chlorine. So you take slaked lime, so calcium hydroxide or lime water basically, dry slaked lime. So you don't take it in a solution, it needs to be dry, like in powder form or like really dry form. You pass chlorine gas through it, right? So it's calcium hydroxide plus chlorine. So in the absence of water, what happens is you take dry slaked lime so that there is no ionization taking place. And when you can prevent ionization, then yeah, so it's not like the chlorine is not going to take the place of hydroxide ion. It's going to replace just the hydrogen atoms from this. So basically, action of chlorine on dry slaked lime produces bleaching powder, and whatever remaining hydrogen and oxygen is the byproduct is water. Okay, so this is the preparation. So action of chlorine on dry slaked lime. Uses are very generic. Bleaching powder, use it for bleaching. So it can be bleaching cloth. Bleaching matlab you remove the color from the cloth, or you bleach pulp and wood. So this is again in the when you're processing, preparation of paper and all, wherever you need bleaching purposes. So that's oxidizing it. Yeah, it's an oxidizing agent. So calcium, this would much rather exist as calcium chloride, which is an ionic compound and it's extremely stable. So calcium oxychloride can give out its oxygen very freely. That is the reason why it's a very good oxidizing agent. So wherever you need oxygen in any particular reaction or a process, this is used as one of the oxidizing agents. And it is very, very harmful. That's why you have memes and all. You wash things with bleach to disinfect it. It's used as a disinfectant. Yeah, these are normal, regular things. Then fill up the fourth row, baking soda. It's not just hydrogen carbonate. The name should be sodium hydrogen carbonate or simply sodium bicarbonate. Add the sodium there. And the chemical formula is NaHCO3. So this is also produced industrially by something called the Solvay process. So this
Ma'am?
particular reaction, yeah.
Like we filled in the table for the first one, then we wrote something about chlor-alkali process. So now we're just filling the table, right? After that, we didn't write about anything.
Yeah. So just fill up the table. If there's any extra things to be written, I'll let you know so you can continue below chlor-alkali process. But abhi ke liye, yeah. So the preparation and properties, you can just read it from your chapter notes, because if you write it again, you'll have to write the exact same thing again. So.
Ma'am, should we mention Solvay process?
Yeah, make a note of it, because if in case you come across the word Solvay process, you should know that that's the preparation of a baking soda. So again, the mixture of NaCl, H2O, you take brine. And then, yeah, chemically you take. So Solvay process is like a whole process. There is a flow chart associated with it. Anybody who's completed this chapter, any of your schools have gone in detail about with Solvay process?
So, even I was wondering, we've
Private
completed
first
this
one in detail.
but we haven't gone so much in detail like chlor-alkali and Solvay process and brine. We haven't done that.
And
Asa only showed us PPT slides giving each information.
just information that this is the reaction.
Yeah, about chlor-alkali. He told you this briefly about chlor-alkali.
Because last year I remember Podar goes in detail with Solvay process. That's why I'm asking anybody else. Vipkyar, what about you guys? Sorry, Billabong, I mean. Elena, Dhruv.
No, ma'am, they didn't do it in detail. Like they told us what brine is and what is a chlor-alkali, but they didn't like go into detail about.
Oh, Solvay process I'm asking about. That also I'm guessing they wouldn't have gone.
No, ma'am, Solvay process.
Okay. Then, Podar, any of your sections have reached this far in this chapter?
No, ma'am. We are going to start this.
Acha, theek hai. Okay. I'll skip it for now. Just write down the name that baking soda is produced by Solvay process. Just if in case you come across any question or if in case any details are asked, I can take it up in a future class. Take about 10-15 minutes, not long. Okay. Baking soda, obviously, naam mein hi hai, used in baking, used in antacids, used in fire extinguishers. Baking soda uses is a little significant. We'll have to get into detail with the uses of baking soda. A lot of give reason or explain type of questions you'll get with this. So once you've noted down the common name, chemical name formula, let me know. And yeah, like Nietzsche, just write down that preparation of this particular preparation is called Solvay process. In case you have hard copies of your chapter notes, you can make a note of it in your chapter notes itself.